So this is going to be 1.2, variables, expressions, and equations. So when you have a variable, that is a letter or symbol used to represent a number. For example, X is a variable. A happy face could be a variable. They can represent different things depending upon if you're in an equation or you're in an expression. If you have a number in front of your variable, that actually means to multiply 2 times whatever your X is. You'll notice that you write variables in italics or cursive. And the reason we do that is so that when you have a plus and a T, you won't get confused. You will always see my pluses written like this, but T's written like this because of that. S's and 5s can get very confusing as well. So just when you're writing your variables, understand that. So that's what a variable is. We then have an expression. And the main part of an expression is that it has no equal sign. And what that means is that your variable can be equal to anything. For example, 2x, and I said evaluate for x equals 3. And in that situation, 2 times 3 would be 6. Now, your variable can be anything you want it to be, and an expression, you have to just designate what you want it to be. An equation is when you have an actual equal sign. In this kind of a situation, your x can only be one answer. If you were going to solve this equation, and we haven't gotten into that yet, but you would divide both sides by what's connected to the variable, and you would get your x equals 5. So in this situation, x can only be equal to 5 because 2 times 5 is the only way you can get 10, if that makes sense. Okay, so in expressions, we have different ways to evaluate things. Hang on just a second while I change paper. Okay, so let's talk about an evaluation actually. Let's say that I had 2 plus W, 4W equals 4. What that asks you to do is to plug in 4 for W. So you would do 2 plus 4 and get 6. Now let's take a look at something that looks like this. So this is saying that I want to take my G and replace it with a 3. So this is what a lot of people will do. And that is actually incorrect, because remember that a number in front of a variable means to multiply. So technically, you should be writing this as this or this. Our next thing is a lot of people will want to multiply the 2 times 3 first. And remember, you do exponents before you multiply. So you always want to do the exponent first. So 3 to the second power is 3 times 3, which is 9. And then 2 times 9 is 8. So let's look at a little bit harder one. And I want to do x is 2. Okay? So plug in. Now, I won't ever use x for multiplication. I'll always use a dot or parentheses. So we're going to plug in 2 for x. So here I have 3 times 2 minus 5 over 2 times 2. So 3 times 2 is 6 minus 5, and 2 times 2 is 4. So 6 minus 5 is 1, and you would want to leave it as a fraction. So there's also a problem with fractions where you have x over 6 plus y over 7 when your x is 1 and your y is 3. So you would do 1 over 6 plus 3 over 7. Now remember, when you're adding fractions, and we talked about this in 1.1, you have to have a common denominator. So we've got 1/6 plus 3/7. I need a number that both 6 and 7 will go into. Now, if you look at 7, you want to list the multiples of what 7 will go into, but eventually you're going to find out that you're actually just going to multiply 6 times 7. That will always work to find your common denominator. It's not always the best way, but it will always work. So my common denominator is 42. 7 times 6 gives me 42. So 3 times 6 is 18. 6 times 7 is 42. So 1 times 7 is 7. Then you add your numerators. 18 plus 7 is 25 over 42, and that's your answer. Let's look at evaluating an expression that's written in words. So let's say that I had 19 times a number. So 19 times a number is just 19x, 19y, 19b. Your homework will tell you what to use as a variable, so make sure you actually type it in. Because let's say that I said 19 times a number, where d is the number or the variable. If I typed in 19x, it would still be technically correct, but the computer would count it wrong because it would have to be 19d. So make sure you pay attention to what the variable is. I would hate for you to get it wrong because you put in the wrong variable. So when you're doing expressions, a lot of times when you see something that's taken from something, it can be kind of confusing. For example, 47 subtracted from a number. Now, a lot of people will do 47 minus x, and that's actually incorrect because 47 is coming from the number. So you're actually going to do x minus 47. If it's addition, it doesn't matter where it goes, but if it's subtraction, it's very important because what if x was 13? 47 minus 13 works, but 13 minus 47 can look kind of weird. So just remember that if you're coming from a number, it's a subtraction problem. I hope that makes sense. And I'm working on the sound. I know it's weird. I need to get a microphone. I apologize. So let's look at another one. The product of 2 and 2 more than a number. This can be kind of tricky, but the and is what gives you the answer that's important because it says the product of 2 and 2 more than a number. So how would you write 2 more than a number? X plus 2. So I want the product of 2 and this, which means I want to multiply 2 times the whole thing. Product means multiply. So it would be this would be it. All right, let's do solutions. I'll give you an equation. Is 3 a solution? So what you want to do is plug in 3 for m. 2 times 3 plus 5 equals 7. What's 2 times 3? 6. Does 6 plus 5 equal 7? No, so this is not true because 3 is not a solution. So then you're going to have really hard ones that look like this. Is 8 a solution? So for every y, you plug in 8. 6 times 8 plus 2 times 8 minus 4 equals 56. 6 times 8 is 48, plus 2 times 8 minus 4 is 4. So now what's 2 times 4? 8. And what's 48 plus 8? 56. Does 56 equal 56? Yes, it's a solution. Can't spell.